Sorry about that. I don't know what's going on with my phone right now. It's like giving me time limits, so I have to figure out how to turn that off. But right now I have 7 minutes and 45 seconds to video, and then I'll probably get cut off again, and then I'll just have to start another one. So I guess this video will be in chunks. Whatever, I'll figure it out later. I want to get it out too, so I'll deal with that later. So here's where it cut me off. I was actually talking. I talked some more, so I'll redo this problem. So if you have this 1 to the 5th, we talked about these are our coefficients. All right, back at it. So I don't use that color. So you're going to take your first coefficient, which is 1, and now these are different. Our x is now a 2x. So the entire 2x will be taken to the 5th power. And then the 3 doesn't come in yet. Plus, next coefficient is a 5. 2x, the whole thing will now go down to the 4th. 3 comes into the picture as the 1st power. Plus, next coefficient is 10. The 2x will now go down to the 3rd. 3 comes up to the 2nd. Plus, next coefficient is 10. 2x comes up to the 2nd. 3 will now go up to the 3rd. 2 plus 3 is 5. We're on the right track. That's how I always kind of check myself. Sorry. Because your powers have to add up to 5. 5 is like the magic number for this problem. Plus, now we've got 5. 2x is now going down to the 1st. 3 is going up to the 4th. Our last coefficient is 1. Oops, 2x is gone. So this should actually be a 3, which will now be to the 5th power. Alright, now we need to neaten it up and make it look more like a polynomial. So we have 1, which is 1. 2 to the 5th is 32. X to the 5th. Plus, now we have a 5. 2 to the 4th is 16. And then 3 to the 1 would just be 3. Followed by our variable x to the 4th. Plus, next term we have the 10 for the coefficient. 2 to the 3rd is 8. 3 to the 2 is 9. And then times x to the 3rd. Plus our 10. 2 to the 2nd is 4. 3 to the 3rd is 27. And then x squared. Plus 5. 2 to the 1st. 3 to the 4th is, I'm pretty sure it's 81. Let me make sure. Yeah, it's 81. Then we have an x, and then just plus, and then 3 to the 5th is 243. Alright, so one more step to neatening this up. First term, is fine, the 32, x to the 5th. Plus, then we have 5 times 16 times 3, which will be 240, x to the 4th. Plus, 10 times 8 times 9 will be 720, x to the 3rd. Plus, 10 times 4 times 27, 40 times 27, 1080 x squared. Plus 10 times 81 will be 810 x, and then plus the 243. So there it is. That would have been horrible to do by hand. That's where that Pascal's triangle really comes in handy. It was still a pretty long problem even with Pascal's triangle. All right, another way to think of Pascal's triangle. This is taking in some of the stuff from the beginning with some of the stuff from the end. Okay, those things taken, when you take so many things so many at a time, your first level for 0, the row 0, is 0 things, 0 at a time. That's the top of your pyramid. Then this is in your second row, or row 1, 1 thing 0 at a time, 1 thing's 1 at a time. Both of those would equal 1. Anything taken 0 at a time is always 1. So this is 2 things 0 at a time. Then the middle is 2 things 1 at a time. That would give you a 2, because 1 plus 1 is 2. And then 2 things 2 at a time. If you evaluated each of these, you would get Pascal's triangle. So row 3 would be 3, 0, 3, 1, 3, 2, 3, 3. And then row 4 would be 4, 0, 4, 1, 4, 2, 4, 3. Hopefully you're seeing the pattern here. And 4 things 4 at a time. Alright, so what we're going to do with this, okay, is kind of funky questions. We're going to look at number 30, which is to find the coefficient, so the number in front, of x to the third in x minus 3 to the 10th power. Okay, you are not going to do x to the 10th power. You're not going to do that whole thing to the 10th power. That would be horrible. But we will think about where it sits. I'm going to be kicked off of this video pretty soon, so I'm going to stop it and start a new video to do number 30.